Now that we have these new formulas, it now allows us to have proofs that have the new formulas built into them. So this question says prove. So we start our proof in the same way that we always start. I'll rewrite my question with an equal sign and draw a line where the equal sign is. Now, our strategies up till now have been like change everything to sine or cos. It's already all in sine. Get a single fraction. Well, it's already a single thing on both sides. There's nothing in our former strategies that will work for this one. But if we look on the left-hand side, we have sine of pi minus x. We could think of this as sine of alpha minus beta. Alpha would be pi, beta would be x. Do you have a formula for that? Yes. Is it on your formula sheet? Yes. So that means you're allowed to use it in a proof. So we could change the left-hand side, sine alpha minus beta, to the right-hand side. Now, if we do that, our right-hand side gets really complicated really quick. Okay? Sine alpha minus beta, well, that's equal to sine alpha cos beta minus cos alpha sine beta. Initially, this seems like it's a bad step, because haven't we made the left side more complicated than we started with? But there are some nice things in here, because sine of pi is on your unit circle. Cos of pi is on your unit circle. What is sine of pi? Oh, 0 times cos of x minus, what's cos of pi? -1 times sine of x. All right, this is kind of mental math I like to do. 0 times cos, 0. Minus a negative will make it positive. +1 times sine. And now we're done. Okay? Careful. Careful in that you don't ever do this. This is bad. Put a big red X through it. What did I try to do? I tried to just distribute sine. Sine is a function. It's not a number. When we have a number or a variable, because a variable represents a number, then you can distribute, right? This is 3x minus 3. But you can't distribute functions. For example, like it used to be on typewriters when they wrote a square root, they'd have to write it like this. They didn't have the line go all the way over. And then they would write maybe 6 plus 3. Okay? This is equal to the square root of 9. Square root is a function. It does something. Is the square root of 9 the same as the square root of 6 plus the square root of 3? Could I have made this function go to both of them? No. But we have to be we're going to be tempted because sometimes we can distribute numbers, and some of you are going to be tempted in this case to distribute sine, but that's not allowed. Okay. I'm going to show you something, I don't know, kind of interesting. When you do things that you're not allowed to, but it works. Okay? Everybody knows how to simplify fractions? Right? You write something in lowest terms. You just cancel out the 6's, right? You can do that. And it works. Does it always work? No. Just happens to be, in this situation, this is bad math, that works. Sometimes students say, well, if I got the right answer, but I did bad math, shouldn't I get full marks? No. This is bad math, but it happens to work. Does it work in other situations? Right? 4 divided by 14, is that, or let's do 24 divided by 14, is that equal to 2? No. It doesn't work there. But it happens to work in this situation. All right? Here, sine of x divided by n is equal to 6. Okay? Can I cancel out the n's? No. But it works. So sometimes we can do bad math and it seems to work. But no, you're not allowed to just cancel out part of sine. It doesn't make sense to do it that way. But sometimes you're tempted, and this will be one of the times that you're tempted. But if you have sine or cos or tan of two things added or subtracted, the only thing you can do is use one of our new identities to figure it out. So you have to say, oh, this is my alpha, this is my beta, and write out all 4 things for sine and cos. Then simplify it to see if it works. Okay, questions for practice on this one are 9, 10, double I, 11, and 14.